So I'm Paul Waller. I'm one of the Principal Tech Directors in NCSC Capability with the National Cybersecurity Centre. And I'm here to introduce today and to set up what will be a great set of talks about the technology, what we can do with it and why it's important. So talking about national security, the mission of NCSC is to make the UK the safest place to live and work online. And how do we do that? We do that by engaging with technologists, with customers, with government, and with industry businesses around the country and indeed around the world to make sure that we have the very best security we can get for the use cases we have and to protect our critical systems. Couple of comments to put some of this stuff in context, looking at the wider picture. This is where we are today. We face a number of challenges for how we organise resilience in our digital ecosystem. We're more connected than we ever were. We're using connected systems for more important things. So critical infrastructure like our power grid, our transport system, our financial system are more connected than they ever were, and they're under attack. We know that, we see that. We've got to figure out how we respond, and we've got to fix problems at root cause. So we see the evolving threat. Lots of things to read about there. I'll come on to a bit more in a bit. Complexity and vulnerability. Everything's interconnected. The complexity of the systems, to just understand what our infrastructure is at a system level is fiendishly hard. And so trying to understand how to fix problems in it and where to address the vulnerabilities we face is itself a really tricky problem. And so it's great to see the collection of expertise and ingenuity we have today crossing government, of course, but also industry, and there'll be lots more later on the sort of the need for innovation in that area and the value of entrepreneurial activity, but also underpinning that the academic research, which has led to some of the engineering solutions that we need to solve the problems we have being made available and giving us the opportunity to deploy them at scale. Talked about complexity and vulnerability. Lastly, the challenging opportunity cost of security investment. It's hard to get people to spend money on security. People spend money on WYSI performance, on low power, on reducing costs, on all the shiny things you see in the devices that you hold and use. But security is important. We know when we zoom out, we look at the national picture, resilience is not an option. We need to improve what we have. We can see the evolving threat landscape and we can see the potential costs at a societal level. And that's why it's important that we focus on how we fix those fundamental components that we have. Lots more details on the actual tech coming later, so I'm not going to dive into that right now. There's talks coming that will explain that in a lot more detail, but I'm just trying to explain the background. Challenges at a slightly deeper level. Products are vulnerable. Software exploits happen. Again, we read about these things all the time. Actually, this is a sort of major societal thing. It's not in ones, twos, and threes. It's thousands of exploits that get discovered. Some of them get exploited. Some of them get patched. All of this stuff imposes costs on people that maintain our systems, deploy our infrastructure, and look after the services that essentially keep the country running. They're often well-known classes of vulnerability. You read a lot about the advanced persistent threat and the sophistication of some attacks, and that's definitely a problem. But more and more often we see large numbers of relatively low effort to exploit vulnerabilities being exploited in systems that have been around for a while, maybe not up to date, maybe not the very latest that they could be, possibly incorrectly configured, possibly vulnerable to classes of attack that have been around for a very long time. Again, it's a well-known stat in this community, but quite a lot of the particular class of vulnerabilities that we often see in memory safety, those concepts are older. They're older than me, and some of the people that exploit them are not. And so this is something we ought to fix. Why are we not there? We're seeing tactical fixes, patches to software. How do we fix problems at root cause? How do we go after the hardware solutions? And that's kind of where we're at with Cherry. Finally, started speaking to that, the costs are borne by society, not by the companies that invest in them. If our critical infrastructure goes down, that's a societal impact. So how do we respond to that as a society? What are the things we can do to invest in fundamental infrastructure, in the foundations of the technology we use to make it easier to build resilient stuff? It's still quite hard work. So what have we been done so far? Again, this is a government context. You're going to hear lots more from the Cherry program and ecosystem later on today. But we've started to sort of put together policy initiatives and work on the government side to start to shine a light on some of this problem, and led by DCIT, also here today, the Department for Science, Innovation and Technology. The PSTI Act helps to standardise some relatively simple but far-reaching principles about deploying connected technology. Are your devices up to date? Do they have keys hardwired into them that can't be changed? If someone discloses you a vulnerability, are you going to fix it? For how many years is that guarantee going to last? These are all questions that really people should be able to ask very easily of products they buy. Sounds simple, very hard to actually run at scale. And so it's important that we start enshrining this in legislation, but also that we put those principles into international standards, because we're in a global marketplace, and fundamentally all the countries need to have similar principles and similar processes if we're going to support the companies that need to sell products globally. So I've got a few shots of things we put out in public, again, to sort of give some background to some of the things that are going on here. This is a relatively recent one, NCSC, along with some partner organisations, publicly stating, here's a threat we see, here's a particular attack vector, here's the kinds of things you need to do. And it's an interesting one because it's targeting thousands of devices. And if you read the detail, which obviously scroll off the bottom here, but I'm sure you can all look it up on a device, the attacks that are being exploited are not sophisticated. They are products that need updates that weren't provided. There are relatively low-hanging fruit from a technical expertise point of view, but the engineering problem of deploying updates at scale is what's making this hard and what's leaving us vulnerable. Another project that's still in flight. I think the consultation side of this has just closed, but the response to the feedback from the public domain, which I dare say some of you will have contributed to, is currently being put together, again within DCIT, supported by NCSC. Software code of practice. How do we establish a agreed baseline for what good software looks like, what bad software looks like, and how to encourage people to sort of pay more attention? Calling out the kinds of vulnerabilities that we'd like to get rid of. This is also a hook for technologies, approaches, engineering activity that, again, makes it harder to write exploitable code, and that's part of the reason we're all here. So what kinds of primitives can we put in products that make it harder to write bad code, that reduce the amount of work a software company has to do to deliver a secure, resilient product, and then to keep it maintained and operational for as long as it needs to be there? Digital security by design. I'm not going to talk about this much because John's up next, so I won't steal his thunder, but an awesome project which most people in the room will be aware of, and if you're not, you're going to hear a lot more about it today because it's the genesis of all the stuff that we're here for. But it's it's a great example of government, industry, academia working together to move technology from pure research to something that is now in a position to be taken forward and commercialized and actually used in our real infrastructure. And that is in a nutshell, is why we're here today, is how do we continue to do that, and how do we bring the kind of resilience we need into the products that are deployed throughout our ecosystem. I'll move on from that one because you'll get lots more than that in due course. Secure by Design's been a sort of byword for us for a number of years now. It's great to be sincerely flattered by CISA in the US, who've put out this guidance, I think in the last year, around how they want to see Secure by Design built into products, again, across the US, but it's essentially a very consistent messaging with the sorts of things we're talking about, talking about memory safety, talking about classes of vulnerability, addressing problems at root cause. I think this is really important for this community because it's an opportunity to see that there's an international market for the kinds of technologies we're talking about. We all know it doesn't work if you can only sell to the UK. You need the global marketplace. Here's an opportunity. This document is co-signed by a large number of agencies in different countries and different continents. NCSC's logos on it, but also look out for a number in Asia, in Europe, and Australasia. So it's not just a 1, 2, 3 agency thing. There's a big deal. I think I've missed one. This one's a little bit more recent. You'll see the same logo on it, but I think jointly issued by CISA and actually the FBI in the States. As an interesting change of approach, is rather than say this is what good looks like, starting to say here's some things we'd really not like to see in products, in projects, in systems that are critical to well, in this case, US national security, but there's a lot of translatable stuff in there. Seeing a list of what companies ought to be doing to eliminate examples of bad practice in their systems and in the products they buy and use. That quote is an interesting one. This is not a published final document, by the way. It's out for consultation. I'm sure that the US community would encourage people in the UK as well to submit responses to that. There's a lot of interesting ideas and suggestions in there, but I like this one. Software manufacturers should publish a memory safety roadmap by January the 1st, 2026. That means that if this becomes formal policy, everyone's going to have to learn how to do this over the coming year. That's a great opportunity for this group to explain to people what memory safety is, what roadmap options might be, and which ones they might like to pursue. So I'll commend you to look at that one and consider a response, perhaps as an alliance, if not as individuals. I've lost a slide. But this is our current piece of work, again, jointly with DCIT and other partners, is to start to look beyond the technical engineering aspects of these solutions, for which I'm very grateful to this community and others for continuing to push that through into operation. But what is the role of government in establishing the right kinds of incentives to spend money on resilience and security, to invest in the systems we know we need them to be there, even when we're under attack or when the chips are down? How do we build that resilience in? And this is very much, as I say, you can see the disclaimer there. This is not for policy. This is for discussion. This is an ongoing conversation. How do we get the sort of macro level levers in the right place that these systems are encouraged to do that? Where is there legislation? What kinds of incentives could we provide? What kinds of national, international conversation do we need to have to encourage this kind of activity? Big part in there to leave you with, I think, is collaborative partnerships. We're all going to need to work together. For me, in this context, that means cross-disciplinary. If we can't explain the benefit of the engineering work done here to the community of financial decision makers, lawyers, policy, legislators, we're going to really struggle to get these things deployed at scale. So part of this is learning to speak across communities and across disciplines, but equally collaboration between companies. The language barrier exists between hardware and software, as many of us know. This is an opportunity to build those networks to understand the impacts of different groups. And I'm really excited to see what we can do here. I think there's a great group of people here and in the community beyond this room that we've worked with so far, and so many more people we can engage with. So I commend you to thank you for coming again, and look forward to what comes along the rest of the day.